Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. I'd like to welcome all of our members into the group and kindly request that you subscribe to our channel and also engage us on the comment section so that we can have your say and contribute towards our overall improvement of skills both in mathematics, physics, chemistry and biology. So today we're going to look at the synthesis of one of the organic compounds, class of organic compounds that we refer to as aldehydes. And as I have mentioned earlier in one of our videos on the synthesis of ketones, I said that aldehydes form a class of organic compounds that fall under the category of carbonyl compounds. And I've said that the concept of carbonyl compounds refers basically to compounds that consist of a structure of a carbon that is been attached to oxygen using those two specific bonds. And of course, in that specific video, we mentioned that these carbonyl compounds are going to act in a specific way that we're going to see, especially when we consider the characteristic of this specific carbon and oxygen that is contained in that specific part. So therefore, for today, we're going to use just an illustration of a transformation of a compound from enol to, of course, an aldehyde. And from our previous video for the synthesis of ketones, we have seen that the conditions for this is an acid catalyzed reaction that involve those specific reagents together with an enol. So for today, the concept of synthesis of ketones, we are going to use the concept of enols, and this is going to undergo what we refer to as base catalyzed reactions, of course, which is contrary to the ketones that we looked at. So in this case, we're going to use the OH group, which is going to be accompanied by that specific reagent. So therefore, that is going to form a basis for us in trying to figure out how we can be able to achieve an aldehyde as a functional group. So we had mentioned diverse uses of these specific products, which are aldehydes, and we said that generally this can be applied in the pharmaceutical industry, and of course the food and beverages. And then lastly, I said that this can be used as well for in perfume industry for as fragrances and other cosmetics, etc. So therefore, in order for us to know how these ones are achieved, and it's good for us to appreciate their specific relevance in our society. So therefore, that one necessitates us to just mention a few of their specific applications. So therefore, I'm going to use an illustration through an example, and we'll try to see how we can be able to achieve this class of organic compounds that we refer to as aldehydes. Now, in this specific illustration, I've given the transformation of an enol to a carbonyl compound that is basically an aldehyde. And I'd said that one of the conditions for this is an base catalyzed reaction. So therefore, I'm going to involve this OH group for a base, of course, in this particular case. So therefore, the second part that I've illustrated below is going to entail the concept of a reaction mechanism. And at this specific point, we're going to see that we are going to achieve an intermediate that can form a resonance structures with the one that has been illustrated below. So in this case, if we are having an alcohol that is being, of course, transformed into an aldehyde, we had talked about the various, of course, attachments at this specific point, and therefore we're going to have a H group at this specific point, which basically has been just ignored to illustrate this basic structure. So therefore, we're going to show how this one is going to be formed. So first, we're going to have this OH group at that specific point, and this is going to be negative. So it's going to pick on this specific hydrogen from this enol group, and this is going to lead to the formation of an intermediate that is going to have this negative form of charge at this specific point. It has lost that hydrogen. So therefore, this is going to result in a reaction whereby this bond is going to move at this, and this is going, of course, to have a subsequent reaction by picking of hydrogen from a water molecule. So I'm just going to have this one represented as that. So therefore, this is going to have, in actual sense, we can just be able to illustrate this one as this. So therefore we can just have this one. It's a double bond, so therefore it's going to have this one come from there and pick that one, and that is going to lead to the formation of that specific final product. I talked about the resonance structure for this specific intermediate. Therefore, we're going to have a formal charge. So that one can resonate between this one and this one, and that is going to pick on a hydrogen at that specific point in order to form a final product that I've illustrated at this specific point. So therefore, if you try to look at this, this is an transformation from what we refer to as an enol to carbonyl compound, which is basically an aldehyde, as we had said. Now, there are various other ways in which we're going to achieve this class of organic compound that we have referred to as aldehydes. And some of the ways in which we can be able to achieve this, of course, is through oxidation of secondary alcohols. And of course, we had basically that's oxidation of secondary alcohols with what we refer to as the pyridinium chlorochromate, which is going to be initialized as PCC. So in any case we come across this one being substituted here, then this is going to be pyridinium chlorochromate that is going to be used as one of the reagents in trying to come up with what we refer to as aldehydes. So this is a mainly form of chromic acid, basically, which is going to be used as, of course, a reagent. And then we can be able to obtain aldehydes through oxidative cleavage of alkenes, whereby we're going to see that the vinylic hydrogens are going to be involved in that specific reaction, or a reduction of carboxylic acids and their derivatives can as well be one of the ways in which we're going to achieve what we refer to as aldehydes, which are the carbonyl compounds. So therefore, among other discussions that we have had on basically the characteristics, reactions, and basically the synthesis of this class of organic compounds, I'm going to put a link in the description box of this very specific video so that we can check related videos. So I hope that we have understood how we can be able to transform enols to carbonyl compound, a group of carbonyl compound that we refer to as aldehydes. And we're going to represent this one appropriately in case we come across this specific kind of reaction. Now, for the others that I've mentioned, of course, we are going to do them in exclusive videos, of course, when we are going to tackle on those specific points. But as at now, this specific transformation from enol to carbonyl compounds, I hope is going to give us a basis of handling a similar kind of organic reactions. So that is it for now, guys. Bye. God bless you.